instead of knots, you could write speed, I would say. Either one of those would be acceptable. You just need to base it on your model for the numbers. Is there anything that you want to push back on, or someone is thinking that we're missing, or is this good to go?
Put the hat on that.
Those knots are predicted, aren't they? For a linear model, so we need that hat on there. Make sure you include your hat. Right, you put the hat on the Y, but you did not put it on the knots there. All right, so you have your linear model. Man, I really do need to reduce the stuff there. I will point out on the understanding check that you will have tomorrow, one of the things I'm going to ask you to do is to justify why you think your linear model is good for the data. So what should you say about your linear model and whether it's appropriate for the data?
Because the line, the trend line,
The trend line?
best fits the data.
How did you know when to stop? So it's equally splitting the points?
Yeah.
So trend line equally splits the points. And what else? Remember, it's called a trend line, so it needs to show the what?
Trend.
And shows the trend in the data. Okay, it needs to show the trend in the data. So again, that's not something you had to write here, but that is a good note to think about if you're on an understanding check. How do we justify the trend line? So I'll go ahead and tell you, I can easily send out a file with data on it, and you have to fit that line to the data and tell me why, and then write about on a piece of paper why it's appropriate. So I do want you to tackle this next part without me telling you too much, because I want you to practice what we just did. Remember to use your last task to help you here.
How do you write the
I want to say, think about what you did on the calculator. You know it's on the paper too, right?
Yeah,
Okay.
I'm just trying to think. Cause we grabbed it, it wasn't it already.
Say it one more time.
We already grabbed it.
Well, and so, okay, let's actually pause. I do want to point this out. Don't forget, we graphed the linearized data, and this model right here, the model is for what? Is this for the linear or the original data? This is the equation of a linearized data, right? This is the model. Model is for linearized data.
Oh, so we're gonna take the cube root or something,
Okay.
and then
So when you say the cube root, you mean the cube root of,
the knots speed.
so the y hat?
Yeah.
So remember, I'm just going to use the y when I'm trying to work with an equation, and then when I do my final model, I'll include the...
parentheses 0.15. Parentheses, Ms. King.
I think you're forgetting something. Remember, it's the cube root of y hat right now,
So you got a cube.
so now you would cube it.
So parentheses, and then put the cube on the outside.
Okay. I just wasn't there yet, I was just writing the model, though, right? So y hat, I'm going to go ahead and say the predicted knots is equal to 0.15x plus 0.88 cubed. Check the appropriateness of that model, right? So again, that's, I don't remember whose model that is, but check the appropriateness of yours.
That's mine.
That's yours.
I just told you. Two more weeks of school, one more week and a half. Yeah, right. Do we go to the next page next week? Oh, no.
You already checked your,
No, I'm saying like,
no, you'd still do it on 3.3.
we can just enter a scatter plot now, right, since we already got.
Mm-hmm. So yeah, you'd want to graph your scatter plot.
Entry function.
Be not saying RPM.
Oh, I forgot to put, sure about that?
Not saying RPM?
For the knots are the independent variable, RPMs were the dependent?
Oh, it's RPM not.
Remember, I thought we said that it was predicted knots, right?
How do I take it out?
So,
Just
we'll go back to menu. Go to graph entry / edit. Go to scatter plot and then scroll up. Nope, hit escape. Go up to scatter plot 2 and then backspace to delete the knots. And then put RPMs there. And then under Y, delete that and put knots.
Wait, maybe.
So again, guys, this is why, I want to point this out, this is why, 1, you want to define your variables from the beginning and reference it, but 2, I would write it out this way. And really, I should have said, instead of X, I should have said RPMs. Okay? So we need to check the appropriateness. All you've done is graph your data.
So.
Well, we gotta find a line though.
Well, we already have the model, right? We want to check the appropriateness of this model. How are we going to do it?
No, grab the original data.
Graph. So you already graphed the original data. Now what do you need to do?
Put in the function.
Okay, so now graph your function, right? The model. So remember, you just wrote a cubic function for that cubic data, didn't you?
You already got it on there.
No, you
We're
don't.
gonna write the cube version.
Right. We want that because remember. So Caleb, you got to remember that model we wrote originally was for the linearized data. We are trying to check our model for the original data.
So we put our function from the very beginning.
Not from the very beginning. From what you just got.
You had to put parentheses.
Well, you're trying to cube the whole thing, aren't you? Look again.
You put plus 88.
You mean 0.88? I know, that was Caleb. Let me see. Okay, so it might be off, maybe, but I'll point out you can't see all your data. What do you need to do so you can see more of your data? Look again, Caleb. Just hit backspace, there you go. Cube it, not cube root. Okay? Now, Caleb's got a similar issue where it looks super off right now, but can he see all his data points?
So
Mine's more small.
zoom out, right?
Zoom out. Not zoom out, zoom
Zoom
data.
No.
So I want you to look again. It looks like it was super off at first, but is it actually that far off?
No.
No. You've got to zoom to the entire set of data, and yours is off a little bit, but it's not terrible.
Put 0.07.
Ew.
Oh, 0.7.
79. We'll see what happens when you change it to 0.79.
0.07? How did you get 0.07? You need 0.7?
That does say 0.79 on there. Huh.
What his linear function?
Yeah, it looks like okay right there. My guess is, so here's what I would do if I were you. So let's all look at Jakim's really quickly, because I think that this is probably, this is an error that you can have and we want to learn from this. So Jakim, So here's something I would note, if you look like this, hey guys, look, is his model for original data a good model?
No, oh God.
Not close. So what I would do, Jakeem, is I would go back to the linearized data and I would adjust my linearized model and go from there. Does that make sense? Well, no, go back to 3.3. Go back to 3.3. 3.3. 3.3. So what I would do, Jakeem, and we're not going to do this right now, but if I were you, what I would do is, so take probably Caleb's model, but what I would do if I were you is, I would actually take off the original data, I would take off the model for the original data, and I would focus on just the linearized one, and adjust that model for the linearized data, okay? Because there's something off with that. So instead of doing that though, I want us to focus here on 4.1. 4.1. Let's at least for sure pay attention to the context. Yeah, 4.1. You missed the shot. You missed the shot.
Yeah, it's still on the floor with that too.
Mm-hmm. We got math to learn, guys. Math to learn. Caleb. So, what do we see out of this context?
That,
I see that in math determine the proof.
I say this.
Okay, so the degrees on the body determines how long they've been dead.
Is that true?
Yes.
Yes.
Because he said he tests on a cadaver. The time it takes to drop from alive, 98.6, which is all in one. Linear, yeah, so pretty much. And like another sentence, the body temp was 5.0 degrees.
That's when it was found.
Exactly, so he can determine how long it's been dead by it dropping from our regular body temperature to whatever it is when he finds it.
But when he was alive, it was 98.6.
Exactly.
So let me ask you a question. Is the time, contextually, and this is an important thing we actually have to think through it, are we going to use the body temperature to figure out the time?
Yes.
Yes, but you can always substitute in for the output to figure out what the input would be, okay? So you gotta think about this logically. Would the body temperature depend on how much time has gone by, or would the amount of time gone by depend on what the body temperature is?
The amount of time on body temperature.
Say that one more time.
The amount of time is
Depends
depends
on,
on the body temperature.
does it really? I want you to think about time. Does time ever give a dump about other things going on around it, or does time just kind of move forward?
The amount of
Time
time
is
the
not
person has
changing.
been dead.
But time
I think the time
independent.
is to determine how long they've been dead.
Time independent.
How long they've been dead determines
The body
the body temperature. So what's the independent variable?
time.
Death time.
That's what I want you to know. So time after death, right? So my x, or my independent variable, that is time lapsed after death, measured in what, by the way?
Degrees.
Time is measured in degrees,
Oh,
huh?
minutes,
Standard.
seconds, hours.
Does it say right here?
No,
No. Go to 4.2. Measured in what?
Hours.
Hours.
man, see, I just said that, Miss Kenny. Come on, man.
Come on, Mr. Kenny, I just guessed it, had no clue!
Dude, I know it's hours, because why would they measure by the minute?
Why
That
wouldn't
makes no
they?
sense.
Why
It
wouldn't
makes
they?
no
In different
sense.
places
They have to measure by hours.
120 minutes, how long is that?
Huh?
120 minutes, how long is that?
1
2 hours.
I just said, you can't.
Right, it took you.
Okay? Could you have measured it in minutes?
Yes.
Okay.
I said 2 hours at the same time you said it.
That's not my point. My point is that you could have measured it in minutes. What's the y or
60 times
dependent
2.
variable? What?
60 times 2. The 2 hours is 2. 60 times 2 is 120 minutes.
What's the y or the dependent variable?
Body temp,
In what?
degrees.
Celsius.
Degrees.
It is in
Degrees what?
Fahrenheit.
Thank you.
Still see it.
Ain't nobody in the US measuring by Celsius. Make sure you define your variables on there.
Time pad.
That right.
No.
Come on, let's
Come
give
Come
us,
on, let's get
give us them 4 minutes.
Hey Siri.
We done got already 4.1 from 2. Come on.
Nuh-uh. Any guesses about what might linearize this data? No idea?
I think it's quadratic.
You think it's quadratic, so you're thinking we should take a
It's
square root?
decreasing though.
I mean, you
Like
can have a
cubic.
What about
decrease in
exponential?
quadratic.
What about exponential?
So let's take a square root to start.
Wait, how much data we got? That's it?
Just a few data points. Okay, so square root of the body
We got
temp.
6 data.
So what do y'all think? Does that look like it's now linearized?
No.
I can check. Let's see. C2 minus C1.
I think it's exponential.
It is decreasing.
Does that look constant?
No.
So it's not linear. Okay.
Exponential.
So
Time or something.
okay, so you're thinking that the original data is exponential? So what do I need to take of the body temp? What did we say was going to be the inverse of exponential?
Oh, I forgot. Square.
Division.
Squared, not division. Division is the inverse of multiplication.
Log.
There's a what?
Log.
There's a logarithm. Specifically, I told you it was going to be the natural log, which what symbol do we use for the natural log? ln. So remember, ln is above that e to the x. So if you go to e to the x, and you hit control and e to the x, that's going to give you the ln, or natural log, of the body temperature. Yes, and so we're going to overwrite data, and that's fine. Woo!
That right.
Look at that!
That right.
Alright, so this is where we will stop, but I want y'all to notice, and we're going to get back into this tomorrow, the natural logarithm linearized what set of data? Exponential. I'm going to make a note to myself because we need to talk about how we should know it's exponential in a second. How what?
You keep showing up that error.
Oh, I'll show you in a second. I know what it's doing. Hey, really quickly, don't forget, these, hey guys, these are the terms, the old terms that are going to be due tomorrow on the graphic organizer. We're going to have some new terms that we'll get into more heavily tomorrow. We're going to have a short understanding check where you have to interpret the variables. Y'all need to make sure you actually study that because we got to move quickly through it. It should not take us long to define variables, interpret the slope and y-intercept.
I ain't going I got Borsa. You been trying to write me a little pass for Borsa.
Should I give you error? Oh, during insertion. So natural. Oh, you forgot the equals. Don't you need that? There you go. Oh, yeah, you need to finish that up. Have a great rest of your day, guys.
Still ain't pick up your